So we're going to switch to sampling, descriptive research, and research design. So the main focus here is going to be on sampling, at least initially, and what we mean by sampling and the various terms associated with sampling. So we want to return to that idea of validity or truthfulness of a causal statement. And again, I want to put a little caveat on here that not all research is focused purely on causal research. Causal means that we have no other alternate explanation for what happened in our study other than our independent variable causing the dependent variable. So did the variations in the IV cause an observable change in the DV in such a way that there is no alternate explanations? And that is kind of the gold standard of true internal validity. But that also does not limit us to that being the only way we can do research. As I mentioned before, the research that we're actually doing, at least faux research in the lab, is looking at the correlation or relationship between two particular variables, two constructs, both continuous. One of them job satisfaction and the other a construct that your group is constructing. That is not going to be a causal research study. That's going to be looking at a correlational research study, a study that's looking at simply the relationship. So it's going to be lower in internal validity. So again, we always have this seesaw effect that the higher we are in internal validity, generally speaking, the more rigorous and more obvious is that the experiment is somewhat a constructed experiment and people recognize that that's what's happening. And therefore, it's harder to generalize. But again, we just want to keep in mind that when we're talking about internal validity, we're looking towards how close can we get to that true experiment where the IV causes the DV, we are completely in control of the experiment. There is nothing else that could be happening in that experiment that could be an alternate explanation for what happened. We're not just looking for a pattern, we're looking for a causal pattern. However, we also then have the validity of the generalization of the results. Do the results generalize beyond the study itself? Would the same results occur with a different sample, a different procedure, a different manipulation, and a different dependent measure? Remember that we start with a construct in the land of theory. So this basically asks if we looked at that same construct with different people using an operationalization of that construct in a different way, or manipulated that construct in a different way, and then measured our dependent variable in a different way, would we still find the same effect? In other words, if it truly is a causal relationship or a valid relationship, a relationship we'd find over and over again, it shouldn't be reliant on just the particular methods we used in this one study and the particular people that we sampled in this one study. The stronger we can make the argument that what we found in the study we would find in other people would be external validity. And we're going to focus more right now on external validity because sampling is more about external validity than internal validity. Internal validity really doesn't care where your sample came from. It simply asks, did you do what you meant to do to that sample? Did you measure what you thought you were measuring? Is it reliable and is it valid? And if you find a relationship, can you trust that relationship? Sampling is more about can you then generalize back from your sample to people that you're interested in, which we will often refer to as your population. So again, one of the common pursuits of all research is to address questions, and that's true of almost any research. Generally, we are testing hypotheses. So based on the questions we ask in past literature, we're going to come up with a testable statement. If we're claiming causation, we also are going to make that hypothesis into a causal hypothesis. And again, this is not going to be all studies. And the claim of causation, or in a non-causal study, the claim of a relationship, did the IVs and DVs really relate to each other in a meaningful way, is internal validity. If we find internal validity, we can then ask, beyond this study, does it make logical sense, or can we even make a methodological argument that it would generalize to other people, from the specific situation in people studying in our study to people in general that were not studied. And this is external validity. So the main tool for making the argument that we have external validity is often sampling. So our sample is selected from a larger population to make these conclusions. So that's the first thing that we want to address, is that when we're talking about sampling, our first step is to ask the question, who are we trying to generalize to? What is our population? So our population in this term, when we use the term population when we're talking about research, We're talking about the target group of people that we want to generalize to. So if we were doing a study about human behavior in general, our population would be all humans, the entire planet. If we were wanting to do a study where we were looking at the impact of educational barriers on secondary education in the United States, our population would be students in the United States. If we were interested in looking at the interventions for people that have late-term Alzheimer's, specifically from an upper class population center in Europe, then we may actually only be drawing conclusions to a very much smaller group of people. We might also be looking at PTSD and combat veterans. That again would reduce the size of our population. But in every one of those cases, we have an identifiable population that we want to make conclusions from our study back to. Sampling error simply refers to any errors that we have in that process of going from the population, and by the way, part of that might be that we poorly defined what that population was to begin with, to then how we actually get our sample in our study. Most studies will have sampling error. There will be issues of trying to get a representational sample from our population. So like I said, we specifically target a population. We decide who is our population. For example, we might decide older adults, so people that are retired over the age of 65. Then we need to ask, can we get that population? We want a sample to be as representational of the target population in general. So again, if it's older adults over 65, is that all adults over 65 worldwide? Is that older adults over 65 in a particular country or culture? Is that older adults from a specific region? What is our population? We want to be fairly specific before we move forward so that we have a good idea of what we're arguing for. Now, in a lot of cases, what's going to happen is we're going to use what's accessible. So for example, if I was interested in looking at older adults over 65, that was my target population, but I didn't have a lot of time or resources, I might simply inquire about some local support groups for retirees, maybe even look at retirement homes to see if any of them would be willing for me to come in and do my study. That's an accessible study, and I then would have a bit of an argument trying to say that this is truly representational of my overall specific target population. We want our sample to be representational as much as our target population. So again, assuming my target population was older adults over 65 in the United States, and my accessible sample was retirees in Edwardsville, Illinois at a retirement home over 65. You can see that I've captured some of the elements I'm interested in, but you can also see how some people could make some arguments. I'm not sure that you're really capturing all older adults. One, you're only capturing older adults that are in a retirement home. What about people that are still working? Also, are there differences in older adults from different regions, from different states, and from different experiences, or even different income levels? All of these could be questions that could be asked if I truly go with an accessible sample, which is often referred to as a convenient sample. But again, that's also maybe all I have availability to. And this is again a time for me to remind you, it's one of the reasons why science often is not any one article, it is a group of articles. It's someone that does a study that has problems with external validity. They have a sample that's not necessarily going to generalize across the board, but it indicates an interesting relationship, and other people decide to research it as well. And those other studies may look at different populations or different samples from that population to see, does it occur in other settings? And that in itself can also build up external validity. So broadly speaking, rules of thumb, how large of a sample do you want? What is the sample size for a study? There's two rules of thumb here. The first one is, broadly speaking, you probably want 30 or more participants in any particular study. You can definitely do less than this. It's just, again, that's kind of a rule of thumb. If you're below 30, there should probably be a reason why you're below 30. The other thing is you want to make sure you have at least 10 participants per variable that you're interested in analyzing statistically. So for instance, if you're looking at gender differences, age differences, and differences in social economic status on job satisfaction, that's 4 variables. You have 3 independent variables. You've got gender, age, and economic status, and you've got an outcome variable, job satisfaction. So you'd want at least 40 people in that study. Now, The next two terms are something that you really need to focus on and make sure that you understand what they are and what the differences are, and that's random selection and random assignment. Random selection is about how people get into your study in the first place. Random assignment is what happens once they're in your study. So random selection is a tool of making the argument that your sample is representational of your population. Random selection is about external validity. Random assignment is how they're assigned to different conditions or independent variables once that sample is in your study. Random assignment is about internal validity. This can also be broken down into kind of sampling techniques, and there's two broad sampling techniques, and both of them are about first identifying your population, and then how do you get people from that population into your study. What's often referred to as probability sampling is what we were referring to in the last slide as random sampling. And the definition of probability sampling is that each member of the population has a specified known chance of being sampled. In other words, you've identified every single person in your population. You have access to be able to contact each person in that population, and then you use some random method to select people from that population into your sample. In other words, if it was adults in the United States over 65, you would have to identify every single adult in the United States over the age of 65, make sure you have access to contact information, and then randomly determine whether or not you can actually contact that person and whether they join into your study. So in a single random sampling, everyone should effectively, a simple random sampling, everyone should have an equal chance of being in your study. Generally speaking, when you can pull this off, it makes a strong argument for external validity. However, it's very difficult to do. And you can kind of see, even if I bring it down to smaller groups, let's just say all I want to do is do a sample that represents SIUE. I still have to identify almost 20,000 students, make sure I have contact information on all 20,000, randomly determine which people in that sample of 20,000 or the population of 20,000 I'm going to invite into my study. And even if I do all that, what if someone says no? They've already somewhat wounded my ability to make an argument that I had a truly random sampling, because now some people were chosen and chose not to participate. So most studies are going to be non-probability sampling. We don't know the probability of someone being sampled from the population because we're just taking a convenient sample. You sample those that are easy to access. And this is where you make logic and basically the procedures you use as your argument for external validity. And that argument may be a strong one, it may be a weak one. So there are things you can do between true random sampling, which is very difficult, and convenient sampling to make that convenient sample better. Like for instance, you might gather population data to find out how many people 65 and over fall into each age band, and then sample, trying to make sure that you get a representational number of people that are 65 to 70, 75 to 80, 85 to 90, etc. So you can also then try to maybe collaborate with other researchers to where you're gathering your sample from more than one location. This would make a stronger argument for generalization, but still not as strong as if you could truly do random sampling. So at the end of the day, when we're talking about sampling as a tool for generalization, we need to identify the population. Once we identify the population, whether it is an exhaustive identification or just a theoretical identification. So exhaustive, you know every single person and you have the ability to contact every single person. Theoretical, you've defined the population fairly well and you've taken steps to try to get a representational sample. You then draw your sample. If you use probability sampling, you actually have an equal chance of getting anyone from that overall population into your sample. Much easier to generalize. More likely, it's going to be a convenient sample. You get who you can and make some argument that it's at least somewhat representational. Once you have that sample, that is who is going to actually be participating in your study. Once your study is complete, and assuming it has good internal validity, you then will make the argument to generalize back to the population from your sample. And again, if your sample was a probabilistic sample, randomly selected, you're going to have a pretty good argument and a pretty good set of methodology to fall back on to say that this should generalize back to the population. The more it was a convenient sample, the more you just used what you had access to, a little bit harder it's going to become more and more difficult to make that generalization.